Hi everyone, welcome to my YouTube channel. My name is Imani Diva and this is my first coding into a video. Please kindly subscribe and I also welcome any suggestions or opinions for the betterment of this solution. If anyone has got a better solution, also welcome and I will take it in consideration. As well, I will make a website which will have the solutions available in case someone wants to have a reference about them. Yep, so let's solve this question. This question is from Codility and it's a cyclic rotation problem. So the question says an array A consisting of n integers is given. Rotation of the array means that each element is shifted right by one index. So we have something called rotation, and it means that each element is shifted to the right. Now, depending on the value of index, but this case it says it's shifted to the right by one index, and the last element of the array is moved to the first place. For example, the rotation of array A 38976 is 63897. Elements are shifted to the right by one index and 6 is moved to the first place. So 6 moves to the first place because it's the last element. When you shift it to the right, it obviously is going to exceed the size of A, so it means that it's taken back to the first position, but 3, 8, 9 and 7 are shifted to the right by one index. That's why the new array looks like this. Now we're told that the goal is to rotate array A k times. That is, each element of A will be shifted to the right k times. Okay, now k times is just like how many rotations are to be done in the array. Okay, now we're told to write a function that takes an input of array A and integer k and returns the array A rotated k times. For example, given A start when k is 3, meaning that this array has to be rotated 3 times. When rotated the first time, we get this. Okay, so 6 is taken back. When rotated the second time, we got this, and when rotated the third time, we got this. For this example, A is start. When rotated once, the return value is start. And for this problem, for this array, it's rotated 4 times. That means it's going to be the same. Okay. Now we are told to assume that n and k are integers within the range 0 to 100, and each element of array A is an integer within the range minus 1000 to 1000. Okay, in our solution we have to focus on correctness. The performance of our solution will not be the focus of the assignment. Alright, so in this case now, let's see how we can solve this question. Now for me, I do think that the things that I ask myself before solving most of the coding questions. So first question that I ask myself is what is the input? Okay, in our case here now, the input is an array of integers and array A of integers n and integer k, which is rotation times of or rotations, say rotations. Okay, and I ask myself what is the expected output? Okay, the expected output for this case is the array rotated k times. Now let's assume, let's assume that the output array is array B. Okay, now in this case, now how can we start going through this question? So we know that each element of A, is going to be rotated k times. Okay, so now how can we put this element in array A to be seen as it's been rotated in that k time? Okay, now we know that our output array is going to be different from what we have as an input array. That's why we assume that our output array is array B. Now I think these are the steps that I would go for. So first I would start from the first element. So basically iterate, I would say iterate through the elements of array A. Okay, now while I'm iterating through the array A, I will then, so this array B, say I want array B to have the same size of A. Okay, now assume that B looks like this. Okay, so now I would say that for example, the first element of A is 3. Okay, now I want 3 to be placed in a position where it's been rotated k times, so its initial index value. So for this case, A is 0, meaning that the first element, its index value is 0. Okay, sorry, index value is 0. Now I want to, because B is going to be my new array, so what I'm going to do is I'm going to take the index value, add the k, rotated k times. Now in this case, instead of 3, so this will be equal to A0. Now in this case, I know 3 is A0. Okay, now in this case 3 will be placed in a position of whatever k is. Now let's assume for this example here, this example here, the k value is 3. Okay, so the k value is 3. Let's assume the k value is 3, so it will be 0 plus 3. Okay, so in our case now, the array B will look like this. B, so there will be no value in element 0, there will be no value in element 1. Okay, there will be no value in element 2, but in this case 3 will be found in that position, but there will also not be value in the element 5. Now if you look at this, you see already that 3 is, if you look here, 3 is found there, and also here 3 is found here. Okay, so which means that it's fine. Now if we take this sort of idea, and we think of we go for the first element. Now the first element in our case is 8. Okay, remember 8 is going to be rotated 3 times, so the I value of 8 will be 1. Okay, so you take 1 plus 3, which is 4. Okay, now if you take 1 plus 3, which is 4, in our case the array B here, look at the fourth the index with the value of 4, which is here. So 0 1 2 3 4. In our case here we will have 8. Okay, if we look at this same idea now, for the second element, okay, which has the value of, if we see here, has the value of 9. Okay, and the index value for this will be 2 at the same value of rotation. So if you take 2 plus 3, okay, this will give us an index value of 5. But in our case now, if you look at the array size of B, which is equal to the size of A as well, it means that it's going to exceed the value of it's going to exceed the size of the array A and B as well. So how can we overcome this array so that makes the element do not exceed the size of the array A after shifting it? Well, if we add this modulus of A of the size of A, meaning that you're going to consider the remaining, okay, after rotating and dividing it with the size of A, we're going to consider the remaining so that it doesn't exceed the size of A. Now in our case here, if you take 2 plus 3, which is 5, okay, modulus the size of A, so we take that, we take the remainder. In our case, the remainder here is going to be 0. Okay, so in this case now, this will be equal, sorry, this is A2. So B0 this case will be equal to A2, and A2 is going to be 9. So we put 9 as well over there. Okay, now we are left with these two. Look at this analogy again. Don't forget this. A dot size. Okay, size of A. Now if we look at the third element, okay, in this case our third element is 7, okay, and the value is 3. Okay, value is 3. So 3 plus 3 is 6. Okay, 6 modulus A lot size. Again, the remainder is how much? The remainder is 1. Okay, 6 modulus, this is going to be 6 modulus size of A. The remainder is 1. On our case, the value 7 will be placed at the position with the index of 1 in array B. Okay, now if we consider this is the last element, we consider the element with the index 4 in array A, which is 6. Okay, and the index value will be 4. Okay, so if you take 4 plus 3, that means we'll be in position 7, but 7 is above the size of A. So if you take 7 modulus size of A, the result here, the remainder here we get is 2. Okay, so we look at where position 2 is going to be in array B. In our case, it's going to be in this position here. So we put the element for this case 6. Okay, now if you look at this solution here, 97638 is the same as the one we have here, 97638, meaning that this solution is valid. Now let's start implementing the solution. So if we start by including the algorithm, so including libraries now that we need, so we obviously need to include vectors because we're going to use vector arrays, and we'll also include, in case we have to print something, which is the IO string, which is going to just space. Okay, now in our case now, we said obviously we have to define the vector array. Obviously because we're putting in integers here, we'll define vector array B to have the same size as vector array A. Okay, now we'll iterate. Okay, so we will start from the first element of array A. We just have to make sure that it's within the size of A. Okay, whatever, when we are moving from the first element, we make sure that we are within the size of A, and then we increment. Now before incrementing, obviously we perform the solution and then we move on to the next element. Now we then say that I plus k is a dot size. If you remember how we explained it over here above, this will be equal to I, and then obviously the required output is the resulting array. So we then return the array B, and this should be okay. And ticks all the boxes. It's fine. And let's submit the task now. Okay, 100%. Alright guys, thank you for watching this video. See you in the next one.